have started a discussion with a new unit, that is image enhancement technique. In that image enhancement video, we have studied about intensity transformation and the types of intensity transformation functions and types of technique used in intensity transformation. In that we have studied about point operation, we have studied about the linear transformation, logarithmic transformation, power law transformation, nth root and nth power transformation. Okay, in this video lecture we are going to start a discussion with histogram equalization. As we know, in earlier video lecture we have started the portion with histogram equalization and what is the meaning of a histogram. So after plotting that histogram, how we used to plot that histogram and what is the meaning of histogram, we are going to solve one numerical on the basis of histogram equalization. So before that we have to understand what is the meaning of histogram and what is the meaning of histogram equalization. So histogram of any image says that if you want to plot a histogram, it is a plot, graphitical plot of occurrence of a pixel. Okay, how many times pixels are occurring again and again in the image, we have to plot the occurrence of that image in the form of histogram. So it is nothing but the process of histogram. And what is the process of histogram equalization? If we want to arrange the occurrence of that pixel or that gray level in such a manner where we are going to spread the value of that gray level equally in the image, that is nothing but the process of histogram equalization. So how we used to spread that value equally into the image? By using the histogram equalization is what we are going to understand by solving this numerical. What numerical says here? Perform histogram equalization of given image. Here we have an image, gray level image with the different gray level values inside that. So we have a gray level value 4, 4, 4, 4, 4 on first row and columns are arranged here. So every value is what I am going to tell you. So these are the total gray level values. So in step 1, what we have to do? We have to arrange it according to the occurrence level. Occurrence in the sense, we have 4 pixels here. So 4 is the gray level. We have 1 pixel, which gray level is 4. How many times this gray level occur in the image? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So how many times 4 occurs there in your image? 14 times. Okay. So 4 occur for 14 times. This is nothing but the occurrence of the pixel. So we are going to calculate the occurrence of the pixel. So how many pixels are there? We are going to start discussion with gray levels. So how many gray levels are there? Multiple gray levels are there. So we are going to arrange that gray level, that is 0, 1, 2, 3, 4, 5, 6 and 7. And each gray level, how many times the occurrence of that gray level is there inside your input image. Okay. So first we have a 0. 0 is not there. So occurrence of 0 is 0. 1 is not there in the image. So occurrence of 1 is also 0. Occurrence of 2 is not present inside the image. The occurrence of that is also 0. Now we are going to move forward. That is number 3. If we are going to watch the image, inside your image we have a 3. So how many times this gray level, that is 3, is occurred inside the image? We have to calculate 1, 2, 3, 4, 5 and 6. So how many times it occurred? 6 times. So occurrence of that pixel is 6. Then we have a 4 occurs for 14 times in the image. Then we have a 5 occurs for 5 times in the image. So you have to write down the occurrence of pixel and gray levels. Okay. So arrange that in this table. We have a gray level starting from 0 to 7. So 0 occurs, number of pixels are 0. For 1 we have 0 pixels. For 2 gray level we have 0 pixels. If we are thinking about a 3 gray level occurs 6 times. So what is the number of pixels? 6 total pixels available in the image. Now 4 gray level value 4 occurs 14 times. So number of pixels are 14. Then we have 5. How many times 5 gray level occur there? 5 times. So number of pixels are 5. 6 is not there. 7 is also not there. So for what is the meaning of pixel value? That is nk. We used to call it nk. So pixel values are arranged here 0, 0, 0, 6, 14, 5, 0, 0. Now, in case number 1, we first have to find out the value of n. So how to find out the value of n? We have a formula for that. N is equals to summation of nk. So these are the values of nk. What we have to do? We have to add all the values. That is what that is going to be the value of n. So if we add 6 plus 14 plus 5, ultimately we are going to get a 25. Now we have value of a 25, that is n here. Okay, so n value is there. Now we have to find out the next column of your chart, that is probability distribution function. How to calculate that probability distribution function? In short form, we used to call it the PDF. Okay, to calculate the probability distribution function, we also have a formula there, that is P of RK. What is the meaning of P of RK? That is nothing but the input variables. Okay, so P RK into is equals to nk by n. What is the meaning of nk by n? So this is the value of nk and this is the value of n. Okay, so in first value, if we want to calculate the first probability distribution function for this pixel, that is this variable, so we have to calculate like this. So 0 divided by 25. So output is what going to be 0. Next we have to do 0 divided by 25. So PDF is going to be a 0. Next for grade level 2, 0 divided by 25, we are going to get a 0. Similar for third grade level, that is for 3, we have a 6 value here. So if we are going to do a 6 divided by 25, we are going to get a 0.24. Similar like that for grade level 4, we have to divide the 14 divided by 25. The output of that is going to be a 0.56. Try to calculate this value, it is going to match the output. Okay, then 5 divided by 25, ultimately going to be a 0.2. Now we have a 0, 0, so 0 divided by 25 is going to be a 0. So now we have find out the value of probability distribution function by using this formula, that is P of RK is equal to nk by n. So we have created the value of P of RK. So P of RK is nothing but the probability distribution function. Now we have to calculate the cumulative distribution function. Cumulative distribution function is nothing but the addition of these two values. So how we used to calculate that? First we have a 0. We are going to write that value as it is here. That is 0. Next we have a 0 here. This 0 needs to get added to this value. Then we are going to get the next value of your cumulative distribution function. So 0 plus 0, 0. As it is, we are going to write this 0 here. Okay, so 0 plus 0.24 is what going to be a 0.24. Okay, similar like that, if we are going to add this 0.24 with 0.56, we are going to get a 0.8. Okay, so 0.8 is what going to be the answer here. Now, if we are going to add this 0.8 with 0.2, we are going to get the answer 1. Now 1 is going to add with this 0, we are going to get a 1. This one is also going to add with this 0, we are going to get 1. So these are the values of SK. So this is how we used to calculate the values of SK. Now last we have to do SK into 7. Why 7? Because the maximum value of a grade level is 7. Okay, so maximum value we have considered here, that is 7. So we have to multiply that 7 with each value of SK. So 0 multiplied by 7, that is 0. 7 into 0, again 0. 7 into 0, again 0. Then 7 into 0.25, we are going to get a 1.68. Next 0.8 into 7, that is 5.6. 7 into 1 is what going to be a 7. 7 into 1, that is 1. Here also 7 into 1, that is nothing but a 1. Now we have created the value of SK into 7. What we have to do in next column? We have find out the value of histogram equalization. Okay, so these are the histogram equalization values. But what we have greater than 5. So it is a round of value that is 6. 7 and it is 7, 7, 7, 7, 7. So these are the new histogram equalization values, and these are the old histogram equalization values. So what we have to do, number of pixels, that is NK, what we have to change that value with new histogram equalization value. So for grade level 3, we have a new value that is 2. So instead of a 3, what we have to write? We have to write a 2. Similar like that, instead of 4, we have to write 6. Instead of this 5, we have to write a 7 here. Instead of a 6, we have to write 7 here. And instead of 7, and it is we have to write a 7 here. So how to arrange that? First, original values are there. 0, 1, 2, 3, 4, 5, 6 and 7. For 0 we have 0. For 1 we have 1. For 2, what we have made? 0. For 3 we have a new histogram value that is 2. What's this? For 3 we have a new histogram equalization value that is 2. So I will get. Then we have a 4. For 4 we have a new histogram equalization value that is 6. So we have to write a 6 here. We have a 5 here. For 5, if we are going to find out, here we have a 7 for 5. After that, for 6 we have 7 here. For 6 we are going to get a 7 here. So we have to arrange that value according to this. Now, how to rearrange that value in your given input image? So this is your given input image, and inside that input image we have a different grade levels. So we have to represent that grade level with new histogram equalization value. Okay, so replace this 4. Watch this. 4 is what get replaced with 6. Stop. So here we have a original value that is 0, 1, 2, 3, 4, 5, 6 and 7. And new histogram equalization values are there. For 0 we have a 0. For 1 we have a 0. For 2 we have a 0. For 3 we have a 2. Is what we have arranged from this chart. For 3 we have calculated here 2, that is new histogram equalization value. So this value we have to arrange into a output image. So how to arrange that into output image? We have an input image like this, where we have a different grade level that is 4, 3, 5 and multiple grade levels are there. So we are going to write that input image like this. Now for 4 we have to write new histogram equalization value for this grade level. So check the grade level, that is 4. New histogram equalized value for that 4 is 6. So replace that 4 with a 6. So we have replaced that 4 with a 6, that is 6, 6, 6, 6, 6. Okay, similar like that, if we have a 3 there, original value is 3, so this is a 3. Instead of a 3, we have a new histogram equalized grade level that is 2. So replace that 3 with a 2. So instead of a 3, write 2 in an output image. So we have written 2 here. Now we have a 5. For 5, is equal to new value of this pixel. So replace that 5 with a 7 and arrange it into your image. We don't have a 6 and 7 in your image, so we don't have to write anything here. So this is how we used to perform a histogram equalization on any input given image. This is a grade level image. On this grade level image, we have solved, we have find out the new histogram equalization levels, histogram equalization values, and we have arranged it in an output image. So in this video, we have ended this histogram equalization process. From next video, we are going to start